Continuing our conversation on angles, let's look at some different terminology. We have standard position. When we're talking about an angle in standard position, which is going to be kind of our go-to, unless we're dealing with bearings, which we'll learn later in this unit, standard position is any angle that begins at the positive x-axis. So our positive x-axis is right here. Now, if we measure from our positive x-axis and go counterclockwise, then we have theta that is positive. If I go clockwise, and I maybe misspoke, so when we go counterclockwise, we get that positive angle. When we go clockwise and measuring from that positive x-axis, that's where we have an angle that is of negative measure. Quadrantal angles are angles whose terminal side lands on the x-axis. So again, starting from our positive x-axis, landing on any other axis. So our first quadrantal angle terminates on the positive y-axis, and this measure of theta is 90 degrees. Our next quadrantal angle starts at the positive x-axis and goes all the way to the negative x-axis, and this measure of theta is 180 degrees. We measure from our positive x-axis all the way to our negative y-axis. Theta is equal to 270 degrees. And if we start at the positive x-axis and go all the way around, ending again at that positive x-axis, that measure of theta is 360 degrees. Coterminal angles are angles that have the same initial and same terminal side. So they begin and end at the same place, but they are going to see different measures. The idea here is that we can continue to rotate around and around and around, adding more revolutions, increasing our angle size, but still starting and ending at the same point. So let's look at an example of 130 degrees. So 130 degrees, since we know a straight angle is 180, we're not quite to that negative x-axis. Here's angle theta is equal to 130 degrees approximately. Now, if I were to continue and add another 360 degrees, what would that look like? So again, let's think about that terminal side. Here was that original 130, but if I keep going all the way around, adding a whole nother revolution, I've added another 360 degrees. So theta is equal to 490 degrees. So now we can see that an angle measure of 130 degrees and an angle measure of 490 degrees begin and end at the same place, making them coterminal angles. Now, I'm going to illustrate this a little differently. Here's that original 130 degrees, but if I measure clockwise, I'm starting and ending at the same place. Now my angle measure is negative. So it's going to be 130 degrees minus 360 degrees, or negative 200 degrees. So to find coterminal angles, this first, or I guess the second picture illustrates that if we add 360 degrees, we'll find coterminal angles. The second is if you subtract 360 degrees, you'll find coterminal angles. Now, because we can continue the cycle of going around and around and around, either direction, counterclockwise or clockwise, there are infinitely many coterminal angles for a given angle. In this next example, we're going to practice determining coterminal angles, but we're going to add some restrictions to it. So we want the angle of least positive measure. So we want it to be positive. We want it to be the lowest value that is coterminal with each angle. That way, we're all landing at the same answer rather than giving any possible coterminal angle. So for 908 degrees, because it's greater than 360, what we're going to start doing is subtracting 360 degrees. When I subtract 360 degrees, I get 548 degrees. This is still greater than 360, so I'm going to subtract another 360. And now I'm at 188 degrees. And I can't go any further. If I subtract another 360 degrees, then I'm going to get into negative angles. So this is the coterminal angle of least positive measure to 908 degrees. For negative 75 degrees, because it's negative, what we want to do is add 360 degrees. So that we get into positives, and negative 75 degrees plus 360 degrees is 285 degrees. And negative 800, again, because we want to become positive, we're going to start adding 360 degrees. So if I add 360 degrees, I get negative 440 degrees. Still negative, we want to add another 360 degrees, giving us negative 80 degrees, still negative, so we need to add another 360 degrees. Giving us 280 degrees. So let's quickly just write a summary. If we're trying to find angles that are coterminal, we're going to add or subtract 360 degrees or multiples of 360 degrees. And we could do this a little bit faster by figuring out what's 360 times 2. Well, that's going to be what, 720 degrees? So we could start with example C, adding 720 degrees and seeing how that works. So we don't necessarily need to add 360 degrees each time. We could start adding multiples of 360 if we are aware of those and familiar with them. A constant angular velocity disk drive spins a disk at a constant speed. Suppose a disk makes 480 revolutions per minute. Through how many degrees will a point on the edge of the disk move in 2 seconds? So this is a conversion problem. We're going to use a technique for evaluating or performing conversions. That technique's called dimensional analysis. Sorry, I had to pause to remember that. So we're going to start with what's given. We were given that the disk rotates 480 revolutions per minute. We're going to set these up as vertical fractions. Now we want to end up getting to degrees and seconds. So we know that 1 revolution is 360 degrees. So dimensional analysis, if I'm trying to get out of that unit of revolutions, I want revolution to be in the denominator and my new unit to be in the numerator. What this allows us to do is cancel out those units of revolutions. Now, we also want to convert to seconds. So likewise, we're going to multiply by another unit conversion, converting minutes to seconds. Since we want minutes to go away, we want minutes in the numerator and seconds in the denominator. Again, we can see that now the minutes are divide out in the numerator and the denominator since we're multiplying across fractions. So we can multiply straight across 480 times 360. So we're going to rotate 172,800 degrees in 60 seconds. We can simplify this by dividing that 172,800 by 60. And this gives us 2,880 degrees per second. Now we want to know how many degrees will a point on the edge move in 2 seconds. So we're just going to multiply this by 2 seconds. Again, that allows us to get rid of the units of seconds, leaving us with degrees. We know that the point will move 500 or 5,760 degrees in 2 seconds.